Okay, for this question here, we're looking at a scenario in which we're going to be using both a quadratic and a linear equation to model a parachute jumper jumping off, I guess, the top of the CN Tower. So here's some of the information given. The height is h, so h over here in meters, and t measures the time after jumping. And we know that up to the point just when the jumper pulls his parachute, the height is modeled by this equation h1. And then the moment the parachute is released, we have a new equation that models the height, and that is h2. So you'll notice if I take a zoom in here in the equations, the first equation has this quadratic term here, or this squared term, whereas the second equation is just a linear term, so it doesn't decrease or go downwards as fast. And I say downwards because they're both negative. So what does this look like in the situation? So I have here our CN Tower. Make this a little bit bigger. And I have our parachute jumper. I'll bring this guy over here. Okay. And what happens is he is going to jump, let's assume, right off the very top of the CN Tower. And then he comes down, and then at this moment, right over here, he releases the parachute, and then he continues to coast down, down, down towards the water. And this is where he lands. So our ground is somewhere over here. That's where he lands, and this is the point. Let me just maybe move him out of the way. This is the point right here. Make it a bit bigger. A bit too big. This is the point where he releases his parachute. So I'll write that in over here. So let's say point where parachute is released. I don't know if it's a double T or one T. One of those is released. Okay, parachute is released at that point, and then we have the other equation, h2, coming on. So from here to here, we have h1, which models the height, and then from this point to the bottom, we have the equation h2. So the question asks, at what time t does he pull the parachute? And the idea here is that at this point where the parachute is pulled, both equations, both h1 and both h2, simultaneously at the same time model the height of the jumper. So at that point, h1 equals h2. And if we go now back to our equations here, what we're saying is that this quadratic and this linear equation at the point the parachute is pulled are equal to each other. So let's write that out. So I'm going to just copy this formula here. Actually, I think I'll do it like this. So I'm going to have negative 4.9 t squared plus t plus 360 equals negative 4. I'm just copying h2. T plus 142. So let me take this guy, move him out of there. I'm going to paste him right here. And again, the question I'm trying to answer is, how long after jumping did the daredevil release his parachute? And by the way, there's my answer. It is 1t. In other words, what is the solution to this equation? What value, t, is going to make this true? So in order to answer that, I'm just going to collect my like terms, bring everything to one side, and take a look at what I end up with. So I get 360 minus 142, and that equals 0. And if I collect, this will give me, oops, this was actually 4t, and together it gives me 5t. And then 360 minus 142 gives me 218, so plus 218 equals 0. Now this equation, because it has this decimal here, might be a bit hard to factor using the decomposition method. So I'm just gonna do a quick plug and play into my quadratic formula, which at this stage I'm sure you're comfortable working with. I'm gonna square my b, oops, wrong one, negative 5 minus 4 times negative 4.9 times 218. And that's all divided by 2 times negative 4.9. So let's see what we get here. I'm going to do this calculation to the side with my calculator. On the discriminant there, that is all this stuff underneath the square root sign. Let's see what we get. 4.9 times 4 times 28 plus 25. So I get 4,297.8 all over negative 9.8. And now, when I take the square root of that, I get plus or minus 65.557 over negative 9.8. Now, at this stage, I'm going to get a positive answer and a negative. The negative will occur when I take the positive of the 65.557, because then it'll be greater than 0, and divided by a negative, it'll be negative. So the answer which will work for me is going to be this negative one here. So let's see what happens. So I'm going to get negative 5 minus 65.557 all over negative 9.8. And if I do the math, I end up with 7.199 seconds, which is approximately 7.2 seconds. Like I said before, the other answer is going to be a negative number. That is this guy over here. An exercise would be to figure out what that means in our scenario. But going back to the original question, if I want to find out at what point the parachute is pulled, well, the answer is 7.2 seconds after jumping.